Okay, tonight we're going to be talking about dating methods and the age of the Earth. He mentioned this gentleman that's going to be speaking, Dan Kraft, and he, at the Apologetics conference up north, is going to be speaking on starlight and time. Starlight and time and the dating methods are probably two of the most important subjects that we have to face in the discussion between creation versus evolution. And those are the two areas where the evolutionary scientists are relying heavily on those two particular areas, because it's a little bit, it's difficult to understand both of them, and there's some good science behind both of them. And one of the struggles that we'll talk about here in a minute, of course, is the evolutionary scientists have some struggles with things like origin and genetics and a number of other, and geology, a number of issues that have a lot of science that is not supportive of the evolutionary theory. These two particular areas they rely heavily on because it's very difficult to talk about. They're very complicated. But anyway, we're going to talk about dating methods tonight, and I'll skip that. We already talked about our topics tonight are 5 basic topics. We're going to be talking about, are long ages necessary? What's the issue with long ages? And related to that are the 2 main methods. We're going to talk about carbon-14 dating and general radioisotope dating. And then we're going to be looking at some other scientific evidences of a young Earth besides those. And then look at the biblical time frame, what the Bible says about how old things are, and look into some details in that. So, to start with, we're talking about 2 conflicting worldviews that are related around all of the subject, but specifically one of the main ones is how old the Earth is. Are the long ages really necessary? So, when we think about science, and note it's in quotes, versus the Bible, which is right when it comes to the age of the Earth, how old the Earth is? How long have we been here? Well, in Genesis, it's fairly straightforward, the controversy. In Genesis, the biblical view is that God created the universe and the earth and all of life in 6 days about 6,000 years ago. It's pretty straightforward, although there's a lot of discussion about that too. Evolutionary science, on the other hand, the very same things evolved over 13.8 billion years, and the earth that's the universe, and the earth about 4.6 billion years. So the question is which is right? They really can't both be true, can they? They are really opposite. So I look at it in terms of asking the question, what are we discussing here? Evidence? Belief? Well, scientists who view the world from a naturalistic viewpoint assume the standard geological timescale is valid. They have to, because there's no alternatives for them. One of the reasons is, and we'll talk about that in a minute, about without the long ages, they have absolutely no chance with the biological evolutionary process. And they have a prior commitment to that, regardless of the facts of science, which you might consider to be a belief system. So we're going to talk about some of those facts. And I personally think that evolutionists are really ignoring the evidence. A few definitions first. When we think about science and history and belief, you can define science in many ways. I like to be simple about things. I think it's making conclusions about events in the present by observations and testing them. In other words, being able to repeat them. Repeat the tests, repeat the evaluations, because we have it right in front of us. History, however, is a little bit different. You're still making conclusions about what's real, but you're doing it about events that happened in the past with witnesses of some type, either that are either written or verbal or other types of actual evidence. A belief system, however, I think is a little bit different. You're still making conclusions about the past, but you're doing it without any witnesses. Nobody was there. Okay? So I look at the situation with evolution. Is it science? Is it history? Or is it belief? Shall we take a vote? Is it all of them? None of them? Or just maybe one? Well, I think science is great at finding out how things work, but it's really terrible at finding out how things work. Actually, how it started. That's the real problem. It's easy, it's relatively straightforward to see how science in our world has translated into marvelous technology because it's there in our hands. It's interesting, though, when you think about the evolutionary science, quote unquote, there's some interesting little issues or problems. This is a quote out of a textbook. Using radioactive dating, scientists have determined that the Earth is about 4.5 billion years old, ancient enough for all species to have formed through evolution. And I really think that's kind of the key focus of what the evolutionary science around the age of the Earth is related, is that word enough. That's a really critical word. Notice that enough time allows evolution to function. Even though evolution scientifically basically falls apart, you know, when you talk about the origins of life or genetics and other topics, regardless of time, it really doesn't matter. Sufficient time justifies the unjustified in many people's minds. And that's the real problem that I see when it comes to the age of the Earth and how it relates to the question of science, evolution, belief, history. So, applied evolutionary time and action. I think Garfield had a real clear picture of what was really going on, where the real problem or the rub is. Garfield's History of Cats, the very first cat crawled out of the sea about 10 million years ago. Evolutionary concept. Fortunately for him, it was only about another 15 minutes before the first mouse crawled out. And you know what I was thinking today? It was also fortunate because right after the mouse crawled out, the first female cat crawled out. That would have been a serious problem. He could have had a meal, but it would have been the end of his line of heritage, wouldn't it? So why is this important? Why is the issue important? Well, I think when you get down to the brass tacks about it, it really talks about the authority and reliability of the Scripture. The issue of the age of the Earth, along with starlight and time, is a real stumbling block to a lot of people. When they compare their faith, what the Scripture says, and what science out here says. It's an extremely difficult stumbling block. And I'm going to give you an example of that in just a minute. It also relates to the basis for the foundation of the doctrine of sin, death, and the atonement of Christ, how that relates to us. It's tied with that first one. I've got to make sure not to bump this. Another issue I think that it really affects is the academic environment and the hostility towards biblical Christianity, really related to the first two. Unfortunately, I think it's the basis for most Christians losing their faith too, especially when we think about young people. Chris was talking about the kids in the school here, how critical that is. And that's one of the reasons why I'm here. And some of us older folks, we have grandkids, right? This is a very important thing for us to understand so that we can work at communicating with them. I also think it leads to poor scientific investigation. And last but not least, it affects our ability to critically think about what we're facing, the questions we face, and really stifle learning. In terms of our relationship with God, it's a very serious issue. One of my favorite sections of the Bible is Romans 1, 18 through 22, and this is just kind of a section out of it. So the wrath of God is revealed from heaven against all ungodliness and wickedness of men who by their wickedness suppress the truth about God. In the following verses, it goes into detail of why. What's the foundation of this? Why God is very, very concerned about this. Well, the creation reveals who God is, and people do not honor God as God. When you're thinking about a naturalistic mechanism for how we came to be, leaves God out of the picture. And he's a little bit concerned about that. Especially he knows how that affects us. Because when we exchange the truth about God for a lie, we start to consider ourselves pretty wise, but we kind of become fools. Chris was mentioning some of the issues that we're facing in our schools today. That's exactly what Paul was saying in Romans, is a direct result of the fact that we've exchanged the truth about who God is for a lie, and worshiping and serving the creature rather than the creator. That's what it says. As a result, God gave us up to a base mind and improper conduct and all manner of not good stuff, like Chris was talking about. And again, the last thing there, it results in dishonorable living, promoting evil practices, as we're all facing today, right? This is an interesting quote from Stephen Jay Gould, an evolutionist, talking about how it constrains openness and critical thinking. Nothing is more dangerous than a dogmatic worldview, nothing more constraining, nothing more binding to innovation, more destructive of openness to novelty. And that's true for the evolutionary viewpoint. Actually, as well, it could be for Christians too, if we miss the point of learning how to think critically. And we'll talk about that in a minute. This is an interesting comment that this geneticist made, an evolutionary geneticist. We scientists have a prior commitment to naturalism, and we are forced by our adherence to material causes to create an apparatus of investigation and a set of concepts that produce material explanations. Moreover, that materialism is absolute, for we cannot allow a divine foot in the door. Does that kind of relate to stifling innovation and thinking when you're pre-committed to that? So why so committed to naturalism? Well, there's a couple of things I think. First of all, it's a fast, quick way to avoid being responsible to God, like it says in Romans. It establishes the foundation of evolutionary science requiring long time periods for the origin of life and new species to form by natural selection. Remember now, there's enough time for all that to happen. And what that does is it's a very misleading viewpoint, because it overlaps or covers over the real serious problems with origin of life and how species change by natural selection. This being that exists that has no reality in truth. And like we talked about before, it challenges the authority of the Bible. So I I've talked to a lot of people, and this is kind of a list of a few things that I've observed of why people believe in millions of years. Well, the main one is science has proved it. The Earth is very old, and that's what we're going to be talking about tonight. Peer pressure. Anybody experienced peer pressure before? Especially in an academic or a work environment, or talking with your friends or family? It's tough to stand on your own 2 feet in the sense of what you think and believe. The fear of feeling ignorant, that's part of that. Science versus religion. Oh, that's a religious viewpoint, right? And I have a science viewpoint. Some people just don't want to hear the information. I like this one. The professor said so. I've heard that a million times. My teacher in high school said that, natural selection made all of us the way we are. Believing in a young Earth ignores the evidence, the science evidence. The Bible does not teach how old the Earth is. Anybody ever hear that one? It creates controversy in the church. I remember my pastor one time, he was giving a sermon on creation, and he said, we're not going to be talking about how old the Earth is, because I know I don't want to ruffle a lot of feathers in our congregation. It's a church right over, not this one, but another one over here. That was a pretty interesting comment. And it's not an important issue. How many have heard that before? I've heard that a million times. It's not really pertinent to my faith. And most scientists believe in an old Earth. Actually, some people say all scientists believe that. You're not a scientist if you don't. Well, there are hundreds of them. In 2015, I was teaching a 2-day class, and I started out the class with a survey of the parents that there were 40 people there, 20 families. They were parents of high schoolers. And I asked them a question. Well, first I asked them a series of questions. I asked them, how many people believe that Jesus turned water into wine? And 100% of them raised their hand. How about you? Anybody here believe that? Okay. How many people believe that Jesus was born of a virgin? I.e., he didn't have a physical father. I.e., God must have created the male chromosomes. Okay? 100% of them said that. How many people believe that he raised Lazarus from the dead? That stinky body that was totally decayed and rotten, just like that, with his word, right? Okay, and then I asked him, how many people, or do you believe that the earth was created in 6 days, 6,000 years ago, as indicated in the Bible? Guess how many people raised their hand? 80% of the parents said they believe the earth is billions of years old. Can you believe that? I just about dropped my jaw and I was just amazed. Especially after they had miracle after miracle, as opposed to what natural science says, believes in what the Bible says. And then at this particular point, there was a major departure. Guess what the next question was? Why do you believe that? And guess what their response was? Scientific radiometric dating proves the earth is billions of years old. Does that make sense? It's very interesting. A total switch, like speaking with forked tongue as far as I was concerned. I don't think they were really that sincere. So going back to the previous slide, why would they believe this? Well, the first one on there was because science has proved that the earth is billions of years old. Well, I think science has proved that you have to have a male and a female in order to have a kid, right? So what's the difference? We're going to talk about that at the end here. So radiometric dating seems to be a real issue. I was really shocked. And I think the thing that was interesting to me is I realized in talking with him that they hadn't asked critical questions. That was the main struggle that they were having. They hadn't asked a couple critical questions. And I actually asked them this. How do you know that that's true? This radiometric dating deal. And they said, well, because the professor said so. That's a real good reason, isn't it? I mean, they seriously said that. Has it ever been observed? Well, that's an interesting question. And the last one, and we're going to be talking about that tonight a little bit, are you making any assumptions? I like this. These came from Mike Riddle, a good friend of ours. And when he put those up on the slide for me, I thought that's really the nuts and the bolts of what we're looking at in terms of what I need to think about. I need to be the person that's working on the critical thinking, even though some others out there are not. That's what I really need to do. How do I know it's true, what I believe or what they're saying? Has it ever been observed? Am I or are they making assumptions? If so, what are they and how valid are they? And that's the crux of what we're going to be talking about tonight. So we're going to be talking about radiation dating, radiometric dating. And tonight I've divided it into two parts. One is about carbon-14 dating. We've all heard that term, right? Everybody? Okay. You probably know more about it than I do, so we'll see. The dating of living or once living plants and animals. Typically we're looking at animals that are dead or plants that are dead and we'll talk about that. Radioisotope dating, I changed the terms a little bit to talk about dating methods that deal with non-sedimentary rock like basalt and granite, those type of rocks, not items that were once living, not organic material. Carbon-14 dating is for that. So just a little quick review. You guys probably know a lot of this, but just for those that might not. Since we're going to talk about carbon-14 first, I was going to use carbon as an example. What is a radioisotope? Well, it's up there good. Here's an example of carbon. On the left-hand side of the screen, you see carbon, a little C there representing the atom, with a 6 on the bottom and a 12 on the top, right? Okay, that is a representation of normal carbon, that's standard carbon, that's not radioactive. The 6 represents the number of protons, which determines what element it is, okay? Or what the type of atom it is. At the top is what's called the atomic mass, which is the number of protons and neutrons which make up that atom, along with the electrons. On the right-hand side of the picture is carbon-14. It's still carbon because it had 6 protons, but it now has 14 neutrons. That's the difference between normal and radioactive carbon. Radioactive C14, carbon-14, is an unstable isotope of carbon. It is radioactive. It decays naturally. Does that make sense? Pretty simple. You got 2 types. And this is true for all of the dating methods. They have whatever you're starting with as the parent, or is the radioactive material, and the daughter is a product of its decay. So there's a product of decay from carbon-14, and we'll talk about that in a minute. Radioactive, what does it mean? So when an element like carbon-14 decays, something happens. It changes. It might break apart. It might lose particles like neutrons, protons, alpha particles, which are basically helium atom, neutrons, depending on the type of decay. And usually there's some type of energy release. Anybody ever heard of an atomic explosion? An atomic bomb, the mushroom cloud? Okay, that is a very rapid, energetic, radioactive process, decay process, that releases immense amount of radiation and energy. We won't be talking about that tonight. So the basis we're going to talk about now, we're using carbon-14 as an example. We haven't got into how we make it, how it comes about, and the details of it, but now we're going to talk about the basis of dating method itself. So the way carbon-14 is created is that nitrogen in the atmosphere is affected by cosmic radiation, and it creates carbon-14, the radioactive isotope. And then later, with time, the carbon-14 naturally decays back into nitrogen. And this is typical of when you have a radioactive atom, it will decay into a non-radioactive relative or daughter, if you will. So the time it takes for the decay process is the basis for radiometric dating for all the methods. Now we'll talk about carbon-14 specifically. It's the dating method for organic materials, plants and animals. How does it work? Are there any assumptions? Do you think there are? The answer is yes. And how consistent is it? So how is it produced, carbon-14? Well, first of all, cosmic radiation coming from basically radiation from the sun, interacts with nitrogen in our atmosphere and forms carbon-14. Then the carbon-14 naturally combines with oxygen and forms carbon dioxide. Does anybody know of any living structure that uses carbon dioxide to live? Plants, through photosynthesis. Sunlight, heat, air with the carbon dioxide, and that forms the structure and the sugars, the cellulose and all the other organic parts. It comes from the carbon dioxide from the air. Fortunately, God was good. He made something that uses what we excel, right? That's a good thing. Then plants are eaten by living animals, insects, whatever, dinosaurs, people. And guess what happens? When the animal eats the plants, who now have a small amount, by the way, that's a very small amount of carbon-14, that is ingested by the animals and becomes part of the structure of the animal. Even you right now. Did you guys, if we turn the lights off, would we glow in the dark? Maybe? From carbon-14? No, probably not. There's not enough in it. But really, there are radioactive natural processes going on right now in your body where carbon-14 is decaying and releasing energy. Did you know that? Right now. Once the animal dies, and it goes into the ground or wherever, and if a fossil forms, for example, at that point where it dies, it's no longer eating plants, and it takes in no more carbon-14. Does that make sense? Because carbon-14 comes from the plants. So the carbon-14 then is fixed in that dead thing. And if it's buried and it becomes a fossil or we dig it up later, then we can measure, actually at any of these stages we can measure the carbon-14. But once it's dead, it takes no more in, and then slowly over time, the carbon-14 will decay and turn into what? Nitrogen, right? Even if it's buried. Okay, so the carbon-14 that's now in the animal that died, being fossilized or in the grave, so to speak, slowly loses carbon-14. So the carbon-14 cycle is the nitrogen is converted to carbon-14. The nitrogen is the result of the decay process because carbon-14 is unstable. And now the question is how long does that process take for carbon-14 to decay? And this is the whole basis for dating. That's what we're getting to. And that's where the term half-life comes in. That dead animal, after so many years, half of the original carbon-14 that's fixed there, and that's the assumption, by the way, that's one of them, decays into nitrogen. So 5,730 years goes by, and half of the original carbon-14 that was in that dead animal decays into nitrogen. So you only have half of the carbon-14 left that you started with. Does that make sense? That's why it's called a half-life. It's not really hard. Another half-life goes by, and this is on the right-hand side, and half of carbon-14 goes away, so you're left with a quarter of the original. And on and on and on it goes until, well, all of the carbon-14 goes away. It's gone. And that's really has a lot to do with how well we can detect it. The age is determined by measuring the amount of carbon-14 remaining in the sample compared to the atmosphere. Remember, the atmosphere is up here and it has the carbon-14 originally. It goes through the plants into the animal. And the assumption is that it's in equilibrium. It's the same amount is being produced by the cosmic rays as is being taken out of the system by plants. Does that make sense? And so we compare what's in the animal to compare it to against what's in the atmosphere, which is theoretically stable, and we can determine its half-life and knowing the half-life, we can measure how much is left, and we can calculate how long it's been since that animal died, right? That's kind of the thought behind it. Maximum range of dating for carbon-14 is 80,000 years, plus or minus. After 80,000 years, we can't detect it even if it was there, because there's so little of it left. So that's the limit. So if somebody says this thing is 75 million years old by carbon-14 dating, what are you going to say? I'm sorry. You do not understand. Because we can't measure it. The assumption, and there's a couple assumptions. One of the main assumptions is to accurately determine the age, the amount of C14 produced in the atmosphere must be constant over time. Well, how old is the Earth? 4.5 billion years. It has to be constant over 4.5 billion years for this to work. Yeah, something like that. Well, is that a correct assumption? And the answer is no. Because even the carbon-14 produced in our modern atmosphere is not constant. You remember what causes carbon-14 to form? Cosmic ray interaction with nitrogen, right? In order for the carbon-14 to be constant, the rate of cosmic radiation would have to be constant. Because basically, nitrogen is pretty constant. It's about 80%, right? However, that's not the case. Over time, we have been able to measure that the amount of radiation that the Earth receives is constantly increasing. And that's because our magnetic field around our Earth, which protects the Earth from the sun, is constantly, the magnetic field which protects it is slowly being reduced with time. So if you go way back originally, whenever, the radiation must have been a more of a maximum than it is today, and therefore the cosmic radiation was a lot lower back then. Therefore, less C14 was produced back then. That means that ancient living organisms absorbed less carbon-14 than they would today and appear to be older than they really are. So if we measure 50,000 years, really? Are you sure? You're making an assumption that carbon-14, the rate has been equal over all that time, which is not the case. So does that make sense? That's part of the critical thinking process, one of the big errors in this. Conclusion, the Earth is younger than indicated by C14 dated. Maybe I'm young after all. Well, how about some facts? Carbon-14, we're saying, indicates young ages. Let's look at some things. Diamonds, for example. How old are diamonds? Well, let's see if the first one. Let's do coal first. 20 to 300 million years old, that's what they think coal is, how old it is by other methods. Well, we find carbon-14 in coal deposits. Wait a second. Carbon-14 after 80,000 years is all gone, right? Or not detectable. But these are, let's say, 200 million year old coal deposits, and we find carbon-14 in them. What does that mean? Maybe they're not 200 million years old. Same thing with oil products. Diamonds are supposedly billions of years old, and we find carbon-14 in diamonds. Did you know that? Diamonds are made of pure carbon, right? Where did the carbon come from? Well, okay. But we can find carbon-14, so they can't be more than 80,000 years old, right? Did you know that they find carbon-14 in fossils? What does that mean for the 80 million year old hadrosaur? Probably not 80 million years old. Probably at most 80,000 years old. Assuming that the carbon-14 was constant during that whole time, which is not a very good assumption. What can we conclude? Any sample older than 80,000 years old should not have detectable C14. C14, if it's detectable, is a good evidence that it's not millions of years old. No 80 million year old carbon-14. Calculated ages are certainly less than indicated, and because of what we think about the change in the cosmic ray levels is consistent with about a 6,000 year time period. That's pretty amazing. Okay, so that's carbon-14. Once living items, organisms. Radioisotope dating, in terms you can change these a little bit, but I did that because it's different than carbon-14 dating. Of non-sedimentary materials like basalt and granite. Same questions, how does it work? Are there any assumptions? How consistent is it? There are many different methods that are used. Remember in carbon-14, we did carbon-14 and related to the amount of regular carbon in the atmosphere. We can't really measure nitrogen because there's too massive of an amount. The decay into nitrogen is not significant compared to the amount of nitrogen. You can't really tell that difference. But we know how much is carbon, and carbon-14 is there. Same thing with these other methods. Rocks, basalt and granite and such, are measured by a number of different methods using radioactive potassium, which converts into argon. Its half-life has been calculated currently to 1.2 billion years. Not 5,730 years, but a lot longer. Uranium lead, which is a very common one, radioactive 238 uranium converts to the half-life into all lead in about 4.5 billion years. Way older than I am. Rubidium strontium is another one. 49 billion years. That's the half-life. That's a long time. That's longer than the universe. So give me a break. There are a number of other methods. So we'll use the first example, a very common one, is uranium to lead. The parent is called the starting element, which is radioactive, converts into the daughter element, in this case lead. Another one that's common, especially for basalt, is potassium into argon. So there's a decay mechanism. You go from one to the other. So if you want to make gold out of lead, you have to have a lead isotope that's radioactive, but I don't think it goes to gold, so you're out of luck. We've tried, and it doesn't work. This is a little schematic of what happens to the uranium-lead decay. It's used to date igneous and metamorphic rocks. It's a multi-step process. You start with 238 on the left-hand side, and it goes through a series of different elements, atoms, each one of them themselves being radioactive, and eventually ends up as lead-206, which is regular old lead that's not radioactive. It's a long process. Each one of those have an individual half-life, and combined together, they equal the total half-life of uranium to lead. Meantime, part of the, again, when something decays, it gives off particles, and we'll talk about these later. Helium atoms are given off at various stages in this process. And we're going to talk about that in a minute. There are 4 decay assumptions that we want to talk about, and these are important to remember and think about. And this is true with all radioactive decay, including carbon-14. It's critical in order to determine age to know what you start with. How much parent? What is the radioactive material? Like uranium-238, how much did you start with? And also, how much daughter is there when you take your sample? Does that make sense? You got to know what you start with, you got to know what you end with in order to figure out how much you have. And you have to make an assumption that all the daughter, all the lead that you found, lead-206, for example, was actually from the radioactive decay. As a fisherman, I use lead weights out in the river. And a lot of my lead weights are in the bottom of the Snohomish River right now, okay? If there's uranium decaying there, good luck in measuring the daughter, because there's a lot of extra lead that came from not the radioactive decay. Another big assumption is once the decay happens, you have to assume that nothing from the outside influences how much daughter or parent is there. Washing in by water, leaching, or other processes. Because, of course, that'll change the amount. And how can you measure how much daughter was produced when you don't know how much daughter there is? A little bit difficult. And the last one, decay rate. Is it really constant? Has it always been 1.2 billion years? Well, there's some scientists with ICR that have measured a number of different isotopes that have generated data that shows that their decay rates do change. But we don't know because we weren't there, were we? And there was a small event back in the past, biblical past, about Noah's flood that changed a lot of things in the world. Could it be that something happened back then? Well, we don't know for sure because we weren't there either. And God didn't tell us about radioactive decay, did he? But it's an assumption. You got to remember that. So there's an assumption that we know how much daughter and parent is there. We know we have to assume that it was all the daughter is from the decay. We have to assume that nothing's been washed in or out. And we have to assume that the rate has been the change. The half-life has always been the same. But is that true? So we are going to have a little skit. Come on up, my student. I have a volunteer student. Notice he's a student. Yeah, you must be going for your 16th degree, but no, not really. Okay. So we're going to talk about an example of how assumptions may or may not be real valid. So, your first name is?
Mike.
Mike. Mike is a student, a grade schooler. His parents have given him an allowance. He earns $1 a day. That's his rate, okay? I want you to take what money you have from your allowance out of your pocket and tell me how much money you have.
Let's see. sure I got about 1 month's worth of allowance.
Well, how much you got?
30.
$30. Okay, he's got $30 in his pocket. So at a rate of $1 per day, how long ago did he start earning his allowance? 30 days, right? Are you sure? That's an assumption, isn't it? What do I know? I know my half-life, don't we? I know the rate. Okay, it's $1 per day. Don't go away. Okay? Based on how much the person has, how long has he been getting his allowance? 30 days, right? Well, guess what? Because I know exactly what happened. The first 5 days he earned $5, didn't he? And that's what actually happened. But then he went to McDonald's and he spent $5. So how much does he have left? Zippo after 5 days. Well, then after McDonald's in the afternoon, he went and mowed a lawn and he got $25. Well, that's a pretty good deal, isn't it? Well, he's a really kind-hearted man or student, and he gave $20 to a mission fund. How much does he have left? $5. This is not rocket science, is it? Okay. However, he did such a good job the first 5 days, his parents got gracious and started giving him $2 a day. Oh, the rate changed. Ooh. So now he has $15, because $2 for 5 days is $10, right? Plus 5 from before, he's got $15, right? Well, he loves creation science. So he went and bought $15 from Chris from his bookstore, and how much does he have left? Nada. Can I have my $30 back? Thank you very much. Appreciate your time. You can sit down. So now he has how much money? Zippo. So, this is a little illustration, is an illustration of the same type of assumptions that are made in radiometric dating. What happened to him? Well, he had a certain rate to start, didn't he? We actually knew it. I knew it, and we knew it, because we were told that, right? But he had some events happen. Some went in, some went out from different sources, didn't it? And then halfway through, the rate changed. Well, that helps a lot. And then at the end, I took all his money away. So there you go. He's got zero. That means he didn't get any allowance. No, he got allowance for 10 days, didn't he? Because we know the facts. Well, think about it if we didn't know the facts. You would assume that he'd been earning money for 30 days, right? And that's the same problem with radiometric dating. Same exact issue with the assumptions. That would cause things to be unreliable, wouldn't it? Perhaps even conflicting. Well, let's look and see what actually happens in practice. These are some dating information from various lava flows. Remember, potassium argon is one of the main methods, and they use it a lot on basalts because they assume that when the basalt is liquid, molten, there's zero daughter to start with. Because guess what? Argon is a gas, a very volatile gas. And volatile in the sense of it doesn't take much temperature to get rid of it. It doesn't burn because it's a noble gas. But theoretically, there's zero in a molten, fresh lava. Theoretically. That's an assumption, isn't it? Well, they've got some data using that method. Roughly 2,000 years ago in Arizona, there was a lava flow and they measured it, and it's dated at 200,000 years. Wait a second, that doesn't seem consistent. In New Zealand, 3 eruptions in 1949, 54, and 75. They dated approximately 275,000 years. using this method. Maybe there's an assumption that was not correct. Hawaii, 1801. It dated, at best, 1.4 million years ago. A problem. Sicily, 72. Well, somewhere between 140 and 350 million, or 1,000 years ago. Are those dates consistent with the dates that we know? We know the dates. Now, the reason is because there's something wrong with the assumptions. I think it's probably the issue that maybe there was not zero argon there to start with. Or perhaps the potassium was off. I don't know. I don't know. Nobody was there. What it does is show there's conflicting, unreliable dates here, obviously. So the assumptions must be not real accurate. Here's another one, locally here, 1980. Anybody know about Mount St. Helens? They dated the lava dome somewhere between 350 and 2.8 million years old. That's really close to 1980, isn't it? Not real consistent. Conflicting dates in the Grand Canyon. This is interesting. This is a group of data. At the very top layer, there was a lava flow, an ancient lava flow that's called the Grand Canyon basalt. And they dated that. It's right at the top there, and it flowed down the side, and they took various samples. And these are the various dates by different methods: potassium argon, rubidium strontium, and a lead. And those are the various dates they dated these to be. Okay, well, if over on the right-hand side, they figure that these deposits were made in the Paleozoic date era, which is somewhere between 250 and 500 million years ago. The dates that they actually measure are significantly different than those dates. There's a big difference between what it should be and what it actually is. It's very interesting, too, that if you look at the lead method on the top, on the basalt, it gives you ages that are real different, that are older than the Precambrian basalt layer that's on the bottom arrow. Does that make sense? So the bottom is, what, somewhere between 790 and maybe 1,340 million years. And the top layer, basalt, which should be theoretically maybe younger, is actually older, depending on which method you use. Notice the methods are real consistent in their grouping too, right? That's really helpful. Notice on the rubidium strontium isochron age for the top basalt is 1,340 million years, and the Precambrian, which is way older than the top layer, is the same age. Wait a second, there's a little problem there, isn't there, with consistency? And this is very common. I like Dr. Morris's statement here. When the same rock is dated by more than one method, it will often yield different ages. We just saw that, right? And when the rock is dated by more than one time by the same method, it will always sometimes give different results. We saw that too. So what does that tell you? What's the conclusion you might come to as a result of that? Maybe the assumptions were not correct. Maybe reliability and consistency is a little bit squirrely. Well, it's kind of like if you want to date something, you just pull a lever and you can choose your own date. That's pretty much what it comes down to. If the assumptions are wrong, remember in our little skit, the assumptions were wrong, weren't they? And we got an erroneous result. If you base your theory on wrong assumption, All of your work can be totally correct. All of our work was correct. These dates are really accurately found, established by the methods we use. They're very scientifically precise. The science is not the problem. It's the assumptions. If your assumptions are wrong, your work can be right, but the result will be wrong or misleading or not reliable. So do you want to go to the bank on that? Not me. Related, radiometric evidence of a young Earth. There are other areas that kind of give an idea that there's different types of results that might cause a question. There was a wood sample buried in a basalt flow that was found about 70 feet under the surface. The wood samples by carbon-14 were dated at 44,000 years. The basalt it was found in was dated at 450 million years. Does that help? Does that give you a lot of confidence? I don't think so. There's another related radiometric or radioactive result that's kind of interesting. That relates to, remember those helium atoms that I told you came out of the uranium decay? Each uranium atom creates 8 helium atoms through that whole process that you see there. So the uranium's in the ground. It's a heavy metal, so it's not going to be floating in the atmosphere. And all the helium that's generated out of the decay originally starts in the rock itself, in the granite or whatever. However, helium is it's a gas. It's a noble gas. It doesn't react with anything. And so eventually it finds its way out into the atmosphere through the interfaces between the rock crystals. Eventually over time, whatever it might be, and we know what those rates are because we can measure it, which is interesting. Eventually, the helium that it was generated by the decay will escape into the atmosphere. Now, from a rate point of view, if all the helium was to escape like the diffusion rates show, we should have a lot of helium in the atmosphere, let's put it that way. However, we don't have a whole lot of helium in the atmosphere. We don't have enough compared to what is estimated as being generated. But if we measure the amount of helium, knowing its diffusion rates, guess what? The age of those rock layers roughly is the biblical ages of roughly around 6,000 years. Does that make sense? So where's all the helium if we have 1.8 billion years, or whatever? There's not enough in the atmosphere to relate to that. It's a little bit of a problem. And I'll just read this. Uranium-lead decay produces the heliums. The helium gas does not remain in the rocks. It migrates to the surface into the atmosphere. If the Earth is billions of years old, we should not find large amounts of helium in the crystals in the granite that have the uranium concentration. For example, uranium concentrates in little zircon crystals. And the folks at ICR took these crystals from boreholes and measured the amount of helium that was left in those crystals. You remember, it should be all gone, right? Depending on the crystal, they found up to about more than half of the helium still remains in the crystals themselves. It hasn't migrated to the surface. So the question is, either the diffusion rate is off, or maybe that crystal's not that old. Well, they know what the diffusion rate is. Assuming the diffusion rate is constant. Well, we're back to another assumption, aren't we? See, it's a little bit of a mixed bag, isn't it? Not enough time for the helium to diffuse out of the granite. That's the whole idea. So that's the result here. The evolutionary model just doesn't match the data. The creation model, about 6,000 years, best matches, depending on what diffusion rate you use, like the current one we know. Maybe I'm young after all. Catastrophic process. Now we're going to get away from radiometric dating. What other geological processes do we know that might show young Earth? It really doesn't take millions of years, I'll guarantee you that. Mount St. Helens, strata forming really quick. You've probably heard this or saw this before. In 1980, we had an eruption, and there's a picture, there's a person there standing at the bottom below the arrow. There's about a 25-foot ash layer there. It happened in one day. About a month later, we had a pyroclastic flow from the mountain eruption, and it generated another 25 feet of micro-layer deposit. Now, if you came by not knowing what happened, you say, well, maybe 1,000 years between each layer. Well, no, that's not what happened, because we actually watched it happen. And then 2 years later, we had another layer on the top, mud flow. But if you came by and didn't know what was going on, didn't know the history of Mount St. Helens and seen these pictures, you might come to the conclusion that it's maybe millions of years old. Well, what about the Grand Canyon? We didn't watch that, did we? Well, we think it's 500 million years old, some of those layers. Well, were you there? I don't think so. Maybe there's another idea or potential for that. It doesn't necessarily take millions of years. Maybe Noah's flood had something to do with that. The Toutle River now flows in a canyon up near Mount St. Helens. Prior to May, 2 years later, after the eruption, there was no canyon there. It formed in 9 hours in one day. It's about 1/40th the scale of the Grand Canyon. Well, maybe it doesn't take millions of years. As the water flowed off the surface of the land during Noah's flood, perhaps Grand Canyon could have formed very rapidly, huh? My favorite. Has anybody ever been over to the Scablands? Dry Falls. Anybody been to Banks Lake and Steamboat Rock? Guess what? Those are canyons carved in solid basalt rock. And do you know what the average rainfall in eastern Washington is? It's about 10 to 12 inches a year. Okay? That's all sagebrush and sand around there. Very interesting. There's no water flowing in those canyons. The only reason why there's water now is they pump it out of the Columbia River at Grand Coulee Dam for the massive Columbia Basin irrigation project. That's why Banks Lake is there. It's not because there's water flowing there. It's pumped over a 900-foot ridge. Banks Lake, in its widest, is about, well, it's 30 miles long roughly and about 1,000 feet deep in solid basalt rock. About 6 miles wide in its widest place. Can you imagine that? You guys have to go over to over to the Dry Falls area and see this for yourself. It's unbelievable to stand in the bottom of those and think about what happened. It didn't happen over a long period of time. They know, even the secular sciences know, that it was a short period flood over in eastern Washington from a lake called Missoula Lake in Montana at the end of the Ice Age. And they figured the lake drained in about 2 days. And there's some controversy about how many events there were, but basically it's still cutting into solid basalt rock. And you can go over there and enjoy that. It doesn't take millions of years. I can't imagine that, solid basalt rock with no water flowing today. Fossil tissue cannot survive millions of years. We've found soft tissue, blood tissue, collagen, proteins in dinosaur bones. And I think some DNA fragments too, right, Chris, I think? We don't know. Protein for sure. These organic materials break down in only thousands of years. Well, maybe the creation model a few thousand years ago best fits that. It's a very significant problem for the evolutionary concept of timing. Maybe I'm young after all, Mr. T-Rex says. Other evidence, there's lots of other short period evidences that we can measure, assuming the rates are constant and have been the same. Sodium concentration in the oceans, comets disintegrating rapidly, erosion of the continents, current erosion rates, sediment buildup in the oceans. They don't match billions of years. The decay of the Earth's magnetic field, remember we talked about that before? It's actually decaying. That's why more carbon-14 is being generated today than in the past. Population growth. I just heard the Chinese are allowing 3 kids per family now. Whoa, thank you a lot. Recession of the moon. We're losing our moon, did you know that? And many more. Well, that's the science. We have about 10 minutes left, and I was going to talk about the last part, which I think is the most fun part too, anyway. The Bible and time teach a young earth. First of all, the Genesis day is really defined in the Hebrew. The meaning of I'm not going to go into detail. This is a subject all its own. I think we've talked about it here before. The meaning of the word yom is a very important distinction. Yom with a number always represents a day, a real day. Evening and morning is described in Genesis. Kind of sounds like a day to me. In Genesis 1:14 to 19, it talks about the day being defined by the sun, moon, and the stars. It's a historical text, not a poetic text that has alternate meanings depending on how you want to look at it. And just the general plain meaning of the text, the sentence structure. There's a lot of solid Jewish scholarly interpretation yield a day as a day. Genealogies, about 6,000 years, if you add them up, depending on how you look at it. And the Bible itself tells us. Exodus 20 says, "For in 6 days the Lord made the heaven and earth and the sea and everything that is in them." So what does that mean? Anybody like to make a guess as to the interpretation of that? Next one, Exodus 31:17. "It is a sign between me and the people of Israel that in 6 days the Lord made the heaven and the earth." Okay, well, another place. Jesus, he had a little view, a little comment to make about creation and the beginning of time. But from the beginning of creation, God made them male and female, Mark 10. According to Jesus, man did not evolve 30 million years ago, or whatever age you want to attach to it. And you know what? I figured out that he ought to know, because he was there. It dawned on me when I was making this presentation that he was actually there. So he ought to know. There's an eyewitness. And I thought, that's cool. And he didn't hesitate just to say that, because he knew that the people he was talking to had the foggiest idea what they were talking about. During his 3-year ministry, Jesus performed many miracles. Remember those we were talking about in that survey? All by his spoken word. Creating food and wine out of nothing, healing ailments, raising the dead, superseding physical laws of nature. He just said it and it happened. Just like that, didn't it? How long did it take him to do that? Just like that, didn't he? Well, guess what? I think miracles were a small-scale example of what he did during Creation Week. He went just like that, and it happened. Because guess what? He was there. He was in the beginning with God. All things were made through him, and without him was not anything made that was made. You can interpret that all any way you want, but it seems to be pretty clear. Has anybody heard this verse as a biblical argument against 6,000 years? But do not be ignorant of this one fact, that with the Lord 1 day is 1,000 years, and 1,000 years is 1 day. I've always thought that, well, if it's really 1,000 years, if you want to interpret it literally, then it took him 7,000 years to make the earth, or 6,000. If you really want to apply this verse. But you'll be applying it wrong, because this verse is not talking about creation at all. Context relates to the last days, not the first days. Scoffers and false teachers. It relates to God's timing and his nature regarding promises being fulfilled. It's not related to creation. So if anyone pulls that verse on you, just open up the Bible and read the section in the context, and you'll see what it's talking about. Does that make sense? Okay. I like these two verses. These are neat verses. Just to kind of summarize what we've talked about. Psalm 118:8. It is better to take refuge in the Lord than to put confidence in man. I look around at me today and I see what's going on, and I say, I'm not sure I really trust a whole lot what's going on. And then I love this next verse. Psalm 111:2. Great are the works of the Lord, studied by all those who have pleasure in them. And I think that's why science is so cool. I think chemistry is the best subject in the world. Better living through chemistry. Did you know that? Everything is chemistry. No, not really. There's a lot. But I love chemistry. So I love that verse. Well, we're done. The earth has not been scientifically proven to be billions of years old. There's just too many reliability issues. The Bible teaches 6 literal days and about 6,000 years ago. And here's the key. Dating methods are based on faulty assumptions. Something we don't know are reliable. Because we weren't there to measure, and we just don't know what happened. Kind of like with our student today. Evidence from nuclear decay supports a young Earth model. You know, the helium and such like that. There are many scientific evidences for a young Earth outside of the dating issues as we went through. And not all scientists believe in billions of years. There's a lot of very smart people, smarter than anybody in this room, that are convinced of what we've been talking about. And most importantly, and that's one of the things I really want to emphasize, is that we have to ask critical questions and be prepared to defend our faith and challenge people to what? Ask critical questions. How do you know it's true? Has it ever been observed? Are you making any assumptions? You think about those. But this is our task, to be prepared to make a solid defense to those who challenge your faith. 2 Timothy 3:15. And we can do it if we work at thinking critically and understand just a little bit of the science. You don't need to be a nuclear physicist. I took a couple nuclear chemistry classes, and they were fun. I spent a lot of time at the nuclear reactor at the UW, and I didn't understand 99% of it. But you know what? It's really cool. I can make a defense just by asking a few basic questions if I know just a little bit of basic information and apply common sense. How can I prepare? Well, I can read science books, magazines, and articles, watch creation science DVDs, attend classes, come to these meetings, go to conferences, visit creation science museums. I'd encourage you to go down to the Mount St. Helens Creation Museum down in Castle Rock. A new director's down there, and he has upgraded his museum to include a fossil collection that was just given to him. It's a wonderful experience. And then he will talk to you about it doesn't take millions of years. There's a message of the mountain down there, and he still has that. And these are just, there's all kinds of groups around. Answers in Genesis, ICR are two good sources. I love ICR's little acts and facts that come every month. It's free. You've got to sign up for it. It's really great.